Good morning, everyone. So it is my proud privilege to get an invitation from Techno College of Engineering, especially from Electronics and Communication Department, because I also originally belong to this department at Tripura Institute of Technology. Uh, so I have started my journey as a lecturer in the institute when it was a Polytechnic Institute in the year 2000. So since then, my role was also changing, our college has also changed. It was originally known as Polytechnic Institute. In 2007, it is converted to Tripura Institute of Technology, and it is converted to a degree engineering college. From 2020 onwards, postgraduate courses are also started, and since my responsibility as a lecturer, then many different responsibilities in the institute. Finally, few months back, I am given the charge of principal also. Which is mostly administrative responsibility, but still that since I am a respected academician, my key interest is there in the academics. So as soon as I received the invitation from one of our students, Kaveri, so I could not deny the invitation, as naturally I am an academician, though holding the charge and finding time at this time, at this period of life, specific answer of life, it is very difficult to maintain the balance between the administration and the academics. But still, let's see how journey progress in sport. And I'm very sure that many of you are working as faculty member in this institution and other institutions. And I have also learned that many of the participants are there in online mode within the state and outside state also. So it is my opportunity to interact with them uh, in a topic which is one of the recent trend in the field of whether we call it in electronics or whether we call it in computer, but these are the recent trends over here. So I will try to put some light on this particular topic. Uh, so let's explore the journey of this particular topic. I hope that you will also enjoy. There are certain concerns. Organizations like food and agricultural organization, they predict that the world population, the textual meaning of this that we all know that world population is increasing and urbanization is taking place. As a result, the cultivable land is getting reduced. Now there is a huge challenge when the population is increasing. To feed this population, we need to have proportionately increased agriculturable land. But the thing is, the trend is opposite side. So then, how to meet this challenging need, this increasing need? So that is a major concern So over here, all this data tells about this. So probably uh, the solution is to make our agriculture practices modernized and efficient so that with reduced amount of land also we can feed the future, the increasing population, and whatever our demand is there, we can maintain a balance between the supply and the demand. So from this angle, modernizing and improving the efficiency of our agricultural practices is very important. So how far we can use the technology in this? So IoT in agriculture focuses on this central theme, and the entire activity, entire discussion today, my deliberation will be revolving around this point. So the presentation outline is arranged in this manner. There are certain challenges in the traditional agriculture. Then how is some light on that? Different type of components that are involved in IoT. What are the different agriculture? In gross, we tell IoT in agriculture, but if we enter inside, we will find subdomains inside. So we will explore what are the different benefits that we are going to get using IoT in agriculture. Then obviously there will be some challenges, and I'll try to put some light on the case study, one or two case study also, and what may be the future directions in this particular field. So we will discuss on that as well. So if we talk about the challenges in the traditional agriculture, then we find that the agriculture sector at present is labor intensive. Manual labor, we mostly rely on manual labor. Then limited technology adoption, this is the greatest challenge. And since we have got piecewise land, ownership of small piece of land is there, especially if we talk, I'm talking in terms of our country only. So that is another issue, because when we go for using the machines in agriculture, so it is inconvenient to apply in small piece of land. Then crop diversity is also one issue, because multiple type of crops being grown in a small piece of land, that also puts some challenges. And limited infrastructure, obviously our rural areas are not connected in a big way, so that the input to the farms, seed and others carrying, and thereafter after harvesting the produce of the agricultural land, they have to be carried to the market. For that also, the road and other related infrastructure, irrigation system, all these are not that way placed at present. Then inefficient resource management is there, because if we rely on the traditional agriculture activities, then when we have to water a agricultural land, so during that time, obviously this is to be, normally it is the flood irrigation system that is being used. So in many time, what happened, we do not find a feedback mechanism in place that how much water exactly is required. So because of this, there will be overuse of water. Water we know a very, very scarcity at these days. So soil degradation takes place because of overuse of water, and energy consumption. When things are not efficient, we know that energy consumption is also a matter, proper energy not utilization. Okay.
Then chemical dependency, we depend on
Then chemical dependency,
fertilizers, pesticides, etc. So if they are not controlled,
etc. So if they are,
so then it may lead
so
to
that it may lead to the degradation of the soil quality, pesticides, and also it leads to the health of the people who we are consuming these products. So that may lead to also, and land fragmentation I have already discussed.
now this
Now this
lack of
another issue is lack of real-time monitoring, which relates to the previous slide also, because we are focusing on mostly on the uh,
manual
manual
labor
manual monitoring.
so
So
when we are
when we are not getting feedback data in time, so there may be some of the actions that are required to be taken at appropriate amount of time that may be delayed, and that may have some catastrophic effect on the crops that are being grown. Obviously, inefficient resource allocation will, if we cannot get the data, real-time data, delayed response to the issues that I have just mentioned. This I can elaborate with an example that suppose the pesticide effects in agriculture field. By the time the effect of the pest get visible to the farmer, by that time what happens? I mean the remedial action taken is part delayed, and because of which there will be loss of crops and the productivity goes down. If there is an automated mechanism based on, suppose there is some surveillance or there is some sensors which can detect that the plants are under the attack of the pest. So if this information is get beforehand or on time, even if they can be get beforehand, then that is the best one. So that before the pest attack, maybe some of the pest may affect based on certain environmental condition. When the humidity is this much or when the temperature is this much, so like that different environmental condition is also associated with the pest attack on the plants. So if these environmental conditions can be understood and can be monitored, then we can be in the alert mode, or there it can be automated. So in that case, what will happen? Such situation can be avoided. Remedial, preventive maintenance, predictive analysis. So all these things can be implemented, and the healthiness of the plants can be maintained, and as a result, productivity of the farm increases. So this happens if we cannot do the real-time monitoring. So these are most of the issues are revolving around this. So obviously, once all these things happen, the quality degrades of the product, and if the quality degrades, then there will be lesser taker in the market. If we get, if we go to, a market, obviously we find two quality of products. As a customer, as a buyer, we will like to purchase the best quality. So if because of pest and others, and some way or other way, the crops get affected, and the return for the farmers will also be affected. So all these issues are there. Environmental impact, soil degradation, water depletion and pollution. If we cannot control the proper amount of water, that may lead to some type of ill, growth of the plants also, overwatering, and overwatering causes the power consumption, energy consumption, because for irrigation we have to use pump and others. There also energy is involved, and as a result, electricity bill is also a matter. So all these issues are there, and biodiversity loss. Obviously, when things are overused, over pesticides and others, So that may lead to like worm type of creatures. They are required. They are called friend of the farmers. But because of overuse or indiscriminate use of fertilizers and pesticides without getting feedback or without proper knowledge, so that may damage the life of such uh, farmer friendly features. So as a result, the degradation of the soil will take place. Chemical pollution, obviously, they are greenhouse emission, and deforestation and land conversion. When we try to expand our agricultural field to new areas by cutting forest and others to expand our agricultural outputs, so such type of effect may be there. So next we are going to talk about role of IoT in agriculture. Now, IoT is basically, we know that in basic IoT system, we employ sufficient number of sensors which monitors the different environmental parameters and feed data autonomously, mostly autonomously to the system, and huge amount of data is being generated which are to be handled in a meaningful way. So IoT devices such as sensors, drones, play a great role. Collect data, real-time data on various environmental factors, especially in terms of agriculture, monitoring the soil moisture, temperature, humidity, crop health, etc. is important. Then this data is transmitted to the cloud-based platform where it is analyzed using advanced analytics and machine learning algorithms, and thereafter farmers can make informed decision about irrigation, fertilization, pest control, and crop management based on these actionable insights derived from the IoT data. So the whole this point is revolving around, we are placing some sensors in the agricultural fields which are giving us the data related to various environmental conditions, and these are being connected to a central node, and from this central node they are actually aggregated first, and then from this central node they are being forwarded using some technique, using some already available wireless or wired technique to a central server that can be a cloud server. So over there this data is being analyzed, and based on the analysis the meaningful insight of the data of this trend is being derived, and which is thereafter informed to the farmers. And farmer, there may be different ways to inform the farmer. As we will explore through this, we will find some other different type of such means as well. So there, the farmers can get the information, and if they get the real-time information, then with this information they can take the proactive actions in the field, and that way the whole system, the efficiency of the whole system can be maintained. So that is how IoT is playing a big role in agriculture. So rest of the points also will be revolving around what I have told. Now, when we can get this data in real time, so that helps us the term called precision agriculture. How much exact amount of watering is to be done? How much exact amount of fertilizer is to be used? How much exact amount of pesticide is to be used? And what will be the different conditions, temperature, environmental parameter on which these are to be applied. So all these things leads to precision activity, and that's gives us to precision agriculture. Obviously, if we can do, then we can reduce the wastage, so resource optimization will be better. if there is already suppose a soil moisture sensor is inserted in the field, and it is giving us real-time data. So based on that, the informed decision can be taken whether the pump to be operated or not. And that can also be even programmed, automized. That even I can be going around or resting in any place of the world. And during that time, my automated system in the field in a remote place may be working for me, and I don't need to bother. This is the power of such IoT-based system. Yeah, that's what the remote monitoring and management that is possible because it is internet-based connection, and if it is required, then I can be monitored just like we know that using CCTV placed in our household premises, we can monitor the different situation at different point of time wherever we go. So in similar way, the parameters that are available, that are being monitored, if it is IoT based, then that can be seen, that can be checked at any point of time, anyway. So that will help us to, if we need to take some action based on that. If it is, suppose in some cases, we know that automated system always still, there are challenges, automated system may not work or may not work as we desire at some point of time. So with manual intervention, because if we get the real-time data wherever we are using this feature, so that we can initiate some manual control over there remotely as well. So that is the added power that is being given to the farmers, especially in livestock monitoring. This is a boon. IoT, use of IoT is a boon because you see, by the time the behavior, the healthy behavior of a cattle when it is allowed to graze in a field, so its normal behavior will be some that can be mapped. A GPS can be fitted in the neck of the cow or buffalo, whatever. We are talking about livestock. So whenever we see that there is a restricted movement or it is not feeling, well, so whenever we feel, unwell, so during that time we know how how our body behaves, how our mind behaves. So similar type of things happen to the cattle as well. So when we monitor, when we have the power to monitor such cattle movement, looking at that, we can understand that there is something wrong or something unhealthy going on in the cattle. So beforehand, we can refer it to the veterinary doctor. We can pay the attention of the doctor, and some remedial actions can be taken so that the cattle wealth we can preserve. So that way, the remote monitoring is very helpful. This is just one example, but there are diversity of it. So if we go into the deeper, then we can explore further. So obviously, everything helps us. All these precautions, timely intervention will help us to enhance crop quality and yield, and our farmers will be with a happy face at the end of the harvesting, which we all like to see. Because you see, it is a hard truth that a farmer's son, a farmer who is earning his livelihood, do not want his or her offsprings, child, to be involved in farming. We all accept that, right? Because this is the scenario in our country. It is because, but a businessman is not like that. Businessman may involve his, and there are generations after which the businesses are going up, family businesses are going up. Because of the low income and the amount of trouble, amount of hard work that has to be involved. Nobody wants. If a generation does it, then next generation they do not like that. My children, my offsprings, they should be doing something better so that they can be earning better. So because reason is like that, because they do not get whatever time and amount money they invest in the agricultural field, equal amount of return and some return they do not get. This is the principal reason. But it may not be true in some other country. Even in our country also, places like Punjab and Haryana, this scene may be slightly different. There they may encourage. So because the outcome, the revenue that earned by the farmers is not proportionate, and at the end of the harvesting, when the season ends, okay, so people's faces are not happy. We know very sorrow situation also because of debt. I mean, trapped in the of debt. Many of the farmers take very unfortunate decision. We often see all these things in newspaper. So obviously, if IoT can help, IoT can revolutionize this sector, and which is very important for the growth of the economy. Because here in our country, its growth in this sector is very low compared to industry and others. So if IoT can do something or some revolution, it can take place. So probably the scenario that I'm trying to depict will change after a period of time. And obviously, without degrading the environment, so if we can cause, if our agricultural practice can cause minimum effect to the environment. We have heard about the pollution condition in Delhi, and one of the principal reasons that has been identified, actually it is not my own, version, from whatever newspaper we have learned, that in some part of the Punjab where crops are being grown, after that the straw is being, though there are other contributors, because Delhi is densely populated, huge number of cars are being, flying over there on the road every day. So other contributors are obviously there, but one of the important contributors is burning of the straw left out of the paddy fields or the wheat fields. So that has been, so if it can be done in a proper way, so maybe such environmental issues can be reduced, technology can be used to address this. So in the next part, we will discuss about components that are used in IoT. I think we are having a gross amount of already idea about the components that are used in IoT, but I am going to talk about the components of IoT with focus in agriculture. It is more or less almost similar type. We can easily understand. Sensors, we use different types, and obviously connectivity is an issue. Connectivity is to be there because as we are talking about IoT, Internet of Things, Internet has to be there. So to deploy the Internet to the last mile, so obviously connectivity is important. Then all collected information has to be put somewhere. First of all, gathered to be somewhere. Then thereafter, some analysis is to be done. And of course, after analysis, we have to, since we want to automate, we may have to start the pump. We may have to start other type of actuators, light on, or different actuators. So for that, they have a role. And farm management software, because ultimately whom we are targeting to, who will be the beneficiary, who will be the user, the farmer. So we need to have a very farmer friendly and software, farm management software, where the farmers should be able to understand, and they should attract, because for older people, especially even handling a mobile phone, a smartphone is a challenging. First of all. Second, there a app or maybe in a laptop or in a desktop, a program that is running, and if that is in some difficult language where the farmer has less competence, so then all these things we design as an engineer or a researcher, we design, we try to deploy, whole system will collapse because it will not attract the user, end user. So for that, the last one is also very important. So we have to design the farm management software in such a way that it is very user friendly and it is easily accepted by the user community. So different type of sensors are being used: soil moisture sensors, temperature and humidity sensors, then for livestock sensors, this type of sensors I was talking about. Then one of the very important sensor is a drone. We might have come across the some government schemes like drone Didi. Drone Didi. It is a government of India scheme, and I was also very happy to learn that. But in this scheme, we know about in villages there are self-help groups run by ladies. So in the self-help group, one or two people will be trained with drone pilot DGCA drone pilot training certificate, so that they can they can fly the drone autonomously by the remote sensing remote device. So, and one drone may be given to one self-help group. Obviously, some model is there. The drone is a very costly equipment as well. So, some subsidies, some loan, that sort of schemes are there. So, then if they acquire such, and the self-help
by
group can
renting this drone to the people who need it in the vicinity.
easily. So, and since it has got, the drone has got a tremendous application, or it is coming up in our country also, in the agricultural sector, apart from other sectors. So, this I'm sure will be a very attractive field to explore. And in relation to the IoT in agriculture, drone has also a big role to play, as far as my personal opinion goes. So if we talk about connectivity, we know these are the basic things, two types, wired and wireless. Wired connectivity normally used for backbone network, for making the backbone network, and wireless, then thereafter the last mile solution by different type of technologies or algorithm. We talk about all these are very familiar terms to us, so nothing much to explain here. So these are all now depending on the application they are being deployed in this particular area. Not only these five, there are more other wireless technologies that can be used like NB-IoT and others. This is a clear comparison between all these five technologies, wireless technologies that has been put in the previous slide. Grossly, we know about these. Like for if we talk about long distance coverage, then we can talk about LoRaWAN or cellular network. They allow us for long distance communication. Then, if we are talking about short range, then it can be Wi-Fi, Bluetooth, or Zigbee. And from power consumption, since these are all, if they are wireless devices, we have to concern about power consumption also. So we have to maintain a balance between these, whether there is a alternate power source like solar, it can be connected over there so that the power remains uninterrupted, etc. etc. All these things, all these parameters will be there in our mind when we use a particular technology for certain
Applications and different
applications. And different applications are there.
these all applications
Uh,
are focusing on the
applications are focusing on the agriculture field only. So next component is the cloud platform and data analytics. So here the role of computer science is very high, especially people from computer science background. So this empowers the farmers to utilize the potential of IoT technology to revolutionize agriculture, enabling them to make smarter, more informed decisions and achieve sustainable, profitable farming operations. So, data collection and storage,
as I already told
as I already told, that the data collected through different sensors that are, I mean, being collected and stored in the cloud platform. And cloud platform offers scalable storage. If we want to upgrade, we can easily upgrade because cloud different type of, I mean, approaches are there for, I mean, hiring the cloud infrastructure, data processing and analysis. Once the data is stored, then next comes the processing of the data and analysis of the data, so that the meaningful insight we can extract. How is the trend? How is the, I mean, trend, and that trend can be related with the previous year's environmental conditions, and based on which we can predict the environmental condition, the atmospheric condition, whether it will be a rain or whether it will be a sunny day. And if it is sunny day, then I mean, how will be the nature of the irrigation? So, etc., etc. All these decisions can be taken, and when we have got, I mean,
the power of AI tools, machine
the
learning
power of AI tools, machine learning,
are very helpful
are
in
very
this part.
in this part.
So based on
Based on, so I mean, all this data when we get, we analyze, and based on which we can make the predictive analysis. What can be the tomorrow's situation? What can be after 1 week? What can be after 1 month, etc. These are some of the actuators that are used in IoT in agriculture to automate solenoid valve, electric motor, fertilizer and chemical injector, then livestock feeders and waterers, where
there will be
sensors fitted on these. The cattle, they after roaming around, or they take water from there, they drink water from there. As soon as the water level goes down below a certain threshold, then maybe the pump will start automatically and replenish the water in the, the I mean, in the tanks, okay, or drinking stations. These are being, uh, I mean, tagged as like this. So all these things can be automated. Automated harvesting equipments, many of them can be controlled remotely also. Drip irrigation emitters, tractor implements, ventilation fans, especially these are used in greenhouses. We talked about farm management software and its importance. So I will quickly progress through. So all these things, all these features makes the farm management software very relevant in the field of agriculture, especially IoT enabled agriculture,
and help
help
us
us
for
for
resource optimization, resource
resource
conservation, etc.
consumption, etc. Now, the role of drone as a component in various phases of the agriculture produce, we can see they are helpful in sensing, even harvesting also. They are being tried to explore, they are trying to being used, spraying pesticide, spraying liquid fertilizer, and they can do very precisely. That is the important thing. Sowing of the seeds on the ground, that can be done by these drones, and if it is done, they are very precise compared to the manual intervention. So that's why the productivity and wastage of the seed or resources can be minimized with the help of these. But in our country, this has to be, I mean, it will take time to develop more interest, more research, more involvement of people in this particular field quickly takes place. Better is the explore of the technology. So different
Applications of IoT in agriculture.
of IoT in agriculture,
We talked about
precision agriculture. I mean, talked about this. And livestock monitoring, another area where IoT is going to help. Even fertility monitoring is also very important component because this thing can be monitored. supply chain management. This is also important contribution of IoT because the temperature trend, humidity trend, all these things can be predicted beforehand, and that may help in the supply chain. How what sort of protection? Because raw products they can be rotted if environmental adverse environmental conditions they succumb to. So if it's in the cold chain or in the uh, during the process of transportation, proper environmental conditions is not maintained, then there
there is loss of
loss.
such important produce, so that can be, and obviously quality of
I
the
mean,
products
important
because
produce.
the rotten products
Obviously, quality of the products will go and products. Obviously, nobody will be like to buy.
crop
Crop
monitoring
monitoring and management. We have discussed about this role of UAV. We have coined
weather
weather
forecasting
forecasting
and
and risk
risk management.
management. Weather forecasting can be done in a better way. So risk management and predictive analysis, all these things will be in place. Water management will be better, and precision use of water can be done. So when we use IoT in agriculture, this sort of benefits we are expecting: increase efficiency, optimize resource use, minimize waste, achieve cost saving in water, labor, and inputs,
Higher
higher
yield
yield
and
and
quality.
quality. We have talked about this point. Sustainability, reduce environmental impact, precision application of inputs, conservation of water and energy resources,
Cost
cost
reduction,
reduction,
reduce labor cost, because labor is a
reduce labor cost.
resource that we need to use. Lot of investment has to be done there.
Labor is a cost investment has to be done there. If it can be mechanized, so obviously the cost involvement for labor can be reduced.
Predictive maintenance
Predictive
based on
maintenance
health of the
based
equipment
on health of the equipment because everything can be monitored. The health of the equipment that are being used that also can be monitored, and as a result, the predictive maintenance
can also be
cycle
initiated, because at the critical time when the things has to be harvested, when the crop has to be
crop
harvested,
has to be harvested. Before during that time itself, the important equipment is out of order.
remote places, then getting it okay, getting it serviced at the critical
At
point of time,
critical point of time that may be challenging.
all these
So
things
all these things
can be done
can be done so that cost reduction, efficiency improvement
can be done.
can be done.
Data driven
Data
decision making, when our decision taken in the agricultural field is based on data, so obviously our decision will be more
will be more
precise
precise
and
and
effective,
effective. So which finally lead to better outcomes and higher profitability.
now all
Now,
these
all
things
these things we have discussed good side of it. Now, what are the challenges that we may face when we go for using such technology in agriculture?
connectivity
Connectivity
issue,
issue.
where
Where
normally
normally the agricultural field lies, obviously in the rural areas. Because in urban places, we are building house on the top of house because there is scarcity of land. Obviously,
with this so precious resource, the land,
so
there we are
precious resource, the land, there we are not going to cultivate. So we will be shifting ourselves to the rural area, and we know the connectivity issue in the rural area. So that is one of the biggest challenges.
then
Then data management and privacy concern. Whenever we expose anything in the internet,
whether it
whether
is
it is a photo in the Facebook or whether it is some type of other thing, we always get concerned that whether it will be misused. Similar may be the case when we talk about especially IoT in healthcare. There, critical issue comes, and maybe in agriculture field also it may be because if it is misused,
some
some environmental condition which is adverse is being shown very comfortable. So obviously the automized equipments which are supposed to be taking action, they are to be in operation based on the environmental condition. They will not, take their action. They will not, operate. As a result, there can be damage in the agricultural field. So obviously, privacy concern or data management, these issues are there. Then you see, in the field of IoT, there is lot of interoperability issue because minimum standardization is there. As it is a very new field coming up, and diverse type of applications are being termed as IoT. So there can be hardware issues because huge number of manufacturers of equipments are there. Huge number of software solutions are there. Whether a hardware purchased from some XYZ company can be interfaced with a software that has been designed by some ABC company. So there is a this interoperability issue, operating system, etc., that we use, whether the appropriate type of wireless technology can be built in, can be operable in the gadgets like Arduino based support system we develop, whether it can be controlled by Wi-Fi, whether it can be controlled by Zigbee, etc. All these issues that will be there. So that are another concern in terms of interoperability. And the last one is very huge bottleneck. All these things we are talking about, things are good, but how much expenditure we have to make? Can our poor farmer afford it? That is a $1 billion question. Now here is the role of government agencies and others. And here is the role of a collective approach from the farmers as well by making society cooperative, etc. Because when we are using machines, it will not be restricted to small piece of land. If we are trying to do that, then it will be most efficient way to do it. So for that, such kind of approach and maybe some investment from the private, like we invest in big companies, big projects of big companies like that, share market and etc. So maybe such type of things are also required in this field also. Some more power supply issues. More we automize, again rural area, we know the power cut, demand. Okay, we are very fresh in our mind about these issues, right? In rural area, even urban area, if power cut is restored in 2 hours, there it will be 2 into 10, 20 hours. So all these things will be there in the rural area, so things will pay, whatever we are discussing. So these are challenges. And actionability, obviously, whatever sensor data, huge amount of data our sensors are generating. Suppose many of are using smart, watch. So it generates huge amount of data. How much data we are able to use it in a meaningful way. It may be a showpiece like a thing. It may remain as a showpiece. We are not able to use it in a meaningful way. Okay, if it is not extended for it. So data sensors are being placed in various parts of the fields. One time investment is done. But what the sensors are giving, if we are not analyzing it in a meaningful way, then there is no use. So that is another data interpretation and actionability. And the another important is that for whom we are making this technology, the end user should adopt it. Their education, their training, investment on that also very important. Even in to the finer details, it has to be maintained. Like I just want to share one story. I am attached to Institution of Engineers Tripura State Center also. So we engage in various type of activities, technical activities, and one of the activity that taken is training the mason. Training the mason. Because mason, there is no formal training. Helper becomes mason after a period of time by gathering some experience, and there are things going on. But when you bring a mason or a helper for training, who will bear the cost of that person who otherwise you are supposed to earn from that? Understood the challenge in the finer details. Because that day he might have earned 500 rupees. You may be offering a lunch to him. But what about his family, who was surviving on his income for that day? So even that details also has to be. Whenever we talk about farmers training, if there are of that, maybe during the planning itself, these issues are to be addressed. So sharing just one of my experience with you. And when we use, see already there is a concept called e-waste. So more electronic product we use after a period of time, they will be also out of order, technology change will be there, hardware removal, obsolescence, etc. will be there. So they will also lead to some environmental hazards if not dealt properly. So that is also a matter of concern. So I will quickly, actually by 12 my lecture was supposed to end. So okay, I will try to focus on two, though there are three. Okay, because this part as a researcher or this community, especially for faculty members, this may be interesting. But I'll just point it out, and many of you are, maybe even I know that many of you are knowing more than me. Okay, because if somebody is doing research in this particular field, then
obviously
they will be knowing more than me. So maybe consulting this sort of papers and others. So I have taken three researchers' work as a case study to produce, and one of that is there in our NPTEL lecture. I used to take this subject in my college also. So there I have come across one of the professors from IIT Kharagpur, Professor Sudip Mishra. He has taken this one work, and that was actually a project from Ministry of Education. So his work I am trying to cite as a first case study, what they are tried to do, maybe some 4 5 years back work. Since this is there, you can further explore or get details in his NPTEL video, which is there, IoT. So this is basically IoT-based dynamic irrigation scheduling system, and they give the name AgriSense. Sensing, is basically for sensors are used, and since it is for agriculture, so it is basically uh, real-time, automatic, dynamic as well as remote manual irrigation treatment for different growth phases of crops life cycle using Internet of Things. Basically, it is dynamic irrigation systems. Because if irrigation is proper, they have identified this particular area to be addressed, and if irrigation is proper, through their work,
they have justified
find that approximately 10% improvement is possible if the irrigation system is made timely and effective. That is what the whole work is revolving around. And they have made the second point you can see, in order to inform the farmer, they have made multimodal approach. One is a visual display. Visual display they have used very interestingly, and this is required in our country also. Some type of LED, bar type of thing. Less water, the LED lower LED glowing, or less number of LED glowing. More water on the field, so higher number of LED. Just like our sound meter. When in our music system, if music is loud, more number of LEDs or displays are available. Similar type of things which are easy to interpret by the farmers. That type of display they have used, and they have also used cell phone to pass on the information based on GPRS base, and they have also used a wakeboard to inform
the user about the different parameters to explore further.
about the different further. And this is it was published in IEEE Internet of Things journal in the year 2020. So the work
Architecture is like this. They have divided it into three layers: sensing and
sensing and actuating layer. So the bottom one is the sensing and actuating layer where some sensors are put in the field. Actually, what they did is
divided
divided
their agricultural land into
small area block. This is of dimension 3 meter by 3 meter, 9 square meter. So over there the sensors are fitted. Then it is solar powered so that the power provision is there, and probably three sensors they have used. We can explore. Anyway, I mean, let us proceed to the slide. So initially the sensors which are fitted, sensor nodes that are fitted in each block, they send the data to the IoT gateway which is there in the central position, and for that they have used Zigbee. And from the central IoT gateway, it is sent to the cloud. Actually, they have used, I mean, storage.
they have created their own
They
server.
have created their own server, as they told, and over there the data is being gathered, and data analytics has been applied over there, and about the different environmental parameters and water conditions, water levels, they send message through SMS and
Other as through
other as through
LCD
LCD
display
display and that bar graph type of thing. So that way they inform the
farmers.
yes, that's what it is written. So this is the electronics part of the sensor node, where we can see on the right top corner there is a Zigbee module which is used to communicate with the IT gateway, and this is how they are being deployed. On the right hand side, solar panel is also there. So all this thing I have described. So this sort of at farmer house they have given this sort of LED graph that I was talking about, and also the LCD module. So then this is the interface website or portal. The farmers can log in. They are given the username, password. They can log into and they can see the environment, different parameters over there. So this is what the product this thing is, and these are the graphs that has been given. Actually, they experimented since these are made in different blocks of 3 by 3 meter square size, and different block has been experimented with different type of watering conditions, and to observe that how will be what will be the effect on the productivity. So all these things here they have, I mean, divided into. I'm sorry to be online actually viewers. Maybe that way it is not possible individually. So here they have divided into four phases: phase one, phase two, phase three, phase four of the entire crop. I mean growth period, right from sowing of the seed to harvesting. Four phases it is divided. And in these different phases, how is the water condition that are being maintained has been explained over here. The red color is basically the soil moisture, and blue color is basically the water level. So you can see that in phase two, in this one and in this one, okay, they are being referred as there are two different fields. I mean, four different fields have been referred. So there are many fields in their paper. They have listed it like this. So here, alternate in first one and last one, they are using. I mean, the watering is done, then water is dried, then again watering is done like that. It is not maintained constant. In these two, they have made constant water. You can see the almost constant water. Moisture condition is that's why flat. And accordingly, they have seen some notable outcome. So one is of one, and B1 is for this field, this part of the field. C1 is for this one, and
C1 is for this one.
D1 is for this one. So accordingly, what they have observed, okay, that the productivity with the automated system has improved over the conventional system. That is what the observation is. And in this particular field, you can see in other three, though there are no data and that reason has also not been explained in the paper. So I am also not able to explain why the other two graphs are absent. But this is the automated systems. So here we can see that the productivity is either equal or better than the other scenarios. But in this case, it is lower, and they have written it that because of leakage of water, which they could not control, or probably they have experimented like that. So productivity is lower on this in this particular part of it. So that's how they try to establish that if the watering irrigation is optimized, then productivity of the field can be improved, and they have got the improvement from up to 10%. Then I'll quickly run through these two, telling you the summary of this. This case study is basically done in Taiwan. I have taken from one of the paper. During this literature survey itself, this has come to me. Because Taiwan is very technologically advanced country, it's a very small country, but they are heavily relying on precision agriculture. Again, the same question, population, because their land is limited, they have to use it in an efficient way, productivity they have to increase. Even they are aiming, they are the rest of the world also by their even small level. Here, this is talking about cultivation, and they claim to be producing very good quality turmeric. Turmeric, especially in turmeric, there is a content called. আমি আমারও এটা জানা ছিল না এর আগে টার্মারিক কোয়ালিটি মিন্স দি কার্কুমিন কন্টেন্ট এটাই হলুদের কালার এবং ফ্লেভারটা আছে বাটা মোর ইজ দি কার্কুমিন কন্টেন্ট ইন ইট better is the quality. Okay. So, and through their effort, they are claimed that in this paper, they have claimed that they could increase it to the 5 times than the normal by all this arrangement. And this is a complete work. Complete work. Not only one part, they have addressed many things in this one. If we explore, they have used 3 fields, and these are some of the parameters that are to be maintained. These are environmental parameters that are to be maintained for healthy turmeric growth, healthy turmeric cultivation, left side. And this is one of the field where there are, you can see in around there is a mass type of thing is there that is called weather station. So 3 fields. One of the field is shown in this one. In the paper, it is there. All these 3 pictorial field is given. This is the weather station. This is the weather station having provision to feed many type of sensors. In the next slide, we will see. Then there are control board. Left side is the sensor control board. Right side is the actuator control board. And this is the heart of the system. Actually, some of the previous researchers of this paper, they have developed an IoT top engine. And this AgriTop, they have also given the name AgriTop. The previous one was AgriSense. So it is using the infrastructure of IoT top. And here, you can see that there are certain connections from input sensors to output actuators. Now, this is basically what are the what are the inputs that should control the actuators? So based on that, connections are being made. So these are dynamic. They have made certain connections for turmeric cultivation. Now the same thing can be applied for another type of cultivation. So based on the requirement, the same general solution can be customized as per the requirement. So and then using, you see, the relay module and others are there here. They are the actuators. Then here they can be controlled using the smartphones or tab, and different conditions can be viewed over here. These are different type of sensors. This is the weather station which are placed in the field, and these are having various types of sensors to control the parameters. So I will not go into detail of this as time is running out. So these are the sensors that are being fitted in the field. This is basically a 3-in-1 sensor which can measure moisture, temperature, electrical conductivity, and the second one B is basically for pH sensor. And insects can affect the field. So for that also they have designed insect traps, and they are being deployed in the field like this way. Deployed in the field like this way. So all these things are given over here, and drippers are connected here. Drippers are there at some point of time. 1, 2, 3. 1, 2, 3 is one is where air. This is basically the paste sprayer to repel the paste at different point of time. So this is the actuator side. Fertilizer in the liquid form is available in the tank. Then pesticide is also there, water is also there. Now based on the requirement, the pump that operates and either take the water, spray the water, pesticide or fertilizer in the places where it has to be injected. The valves are fitted throughout the field. And through this picture, who is the leading researcher over here, he is trying to show that he is in an airport. Being in an airport, he can remotely control, monitor his field condition. That is what is being depicted by this picture. So that is the power of IoT. So all these parameters that can be, visualized, monitored, and if suppose some abnormality goes, these parameters are being monitored. So abnormal situation in the sensor input is being detected. So that way the attention of the user can be automatically drawn. And this is, they have also done the power consumption analysis. So where during the time when the motor is on, this bar graph is showing power consumption, and during night time the bulbs and others that are spread in the field, they glow. That's why the power power consumption is higher from evening 7 p.m. to next morning 5. Then they are sort of there. That's I have already discussed about. And you can see this is traditional turmeric agriculture. The growth of the plant is also visible, and they claim that the curcumin concentration is 5 times more, and this is what the final product is. Very interesting paper that I have come across. Another one, this is growth. So since time is less, so I will not go into detail. Here, only thing is that the sensors are planned in different parts of the field. Now, a drone used to travel around in a certain interval of time, and using a LoRa module which is being planned. Using this picture explains everything. This is a LoRa module. Sensors are fitted at different part of the field, and these are being aggregated. This is the weather stations. These are sensors which are there on the field. Now, all this thing is collected here, and over an interval of time, the drone is being programmed. Software is programmed using path planning is done, that in which path it will move around. So and then it goes and collects the data and forward it to the cloud.
data can be monitored and these are
ground station. So the data can be monitored. These are the sensors that are used in these weather stations. And this is the block diagram of the wireless connectivity. Four different type of sensors are fitted to the weather station. Then using LoRa connectivity, they are being sent to the wireless server. Then from the server, the drone takes the data and it sends to the cloud using 4G technology. And this is what the algorithm. And this is how these are the weather stations. These are the weather stations. So a drone makes a path planning and moves through this path and collect data and then using the 4G it sends to the cloud. And the real-time data is collected that way. Thereafter it is analyzed and given to the farmers. So these are the data that are being collected. You can, if you see minutely, if it is possible to see, then you can see this data is for in 1 year, one complete year. This is somewhere 320, means March 2020. Then it is 321, March 2020. So for one complete year, the data, continuous data about the four different parameters, high. So all this information is collected, like temperature, humidity, moisture, solar radiation, because solar radiation directly relates to the temperature. So, and based on all these analysis, in the paper itself, they have given uh, suggestive measures that they have given to the farmers. It is a glimpse of that, the list is long. So, there are future directions. So, more technological advancement, integration of AI and machine learning, then edge computing, where the sum of work can be done locally. Robotics and automation systems will help in efficiency. And
it needs improvement of
climate resilience and adaptation.
all these things as there is
All these things, as they are interoperability issue, so collaboration among all the stakeholders is important for this field to further progress and popularize. So finally, this is the summary that IoT is going to help the farm
especially us intern so that the quality of food
and the profitability of the farmers, economy, etc. will be affected, improved by this technology. So thank you very much for your passive listening. These are some of the references.
So thank you so much, sir, for your valuable session.
Thank you, sir.
So thank you so much, sir, for this valuable session. The session was really so informative. The participants who are present here, if any one of you have any query regarding the session, kindly ask.
It's also very helpful and our colleagues also. Thank you, sir. Thank you.
I have a question.
Yes, yes.
Actually, in the case study, we have shown a slide that was showing with alert sign. So I think this was for soil testing, I think.
Okay, we can see that. I quickly gone through.
Yes, sir. Yes. So, the second one, the
This
second
one, this
class,
one.
yes, sir. What is the reason for that, the specific upgrading of alert? Because this was well normally. So what may be the reasons of that upgrading of this graph? What is
Okay.
possible reasons?
Yeah, actually, you have, I mean, identified the correct point, but actually, reason is also not known to me. To be very frank, because my information is limited to the paper that is, described over there. Okay. So maybe certain, what it is measuring, let me see. Alert point, time series of the sensor, more info. So what it is explaining, soil moisture, right?
Yes, sir. You are putting out the first monster.
It may so happen, by our intuition, what we can predict, that all of a sudden there is a rain. Use rain, night and accumulated water. Yeah, that may lead to this sort of situation.
So we would like to conclude. Thank you.